Hello, everyone. Welcome to this week's Entry Life. Today we have Lubron with us to tell us a little bit more about the cloud provider vSphere, right?
Yeah.
Lubron is a new Lubron is a new friend of Entry Life, right? So, would you like to tell us a little bit about yourself before going to the cloud provider?
Yeah, sure. Thanks, Shinji. Hello, everyone. I'm Lubron John. I worked for VMware for 6 years,
Wow.
and currently I worked in the Tanzu networking team. Uh, yeah, we are responsible for integrating different load balancer service to TKG, uh, or responsible for the node networking setup or the proxy setting or yeah, that's pretty much it.
Yeah.
And I also sorry, yeah, I'm also the maintainer of Wider vSphere, and that's why today I'm gonna share a little bit of knowledge of mine on the cloud provider vSphere.
Yeah, we're very happy you joined us today. And also, Lubron has experience developing the TKGS and TKGM. So today he's gonna tell us a little bit about the difference between them and like how the cloud provider works in both TKGS and TKGM. Okay, I'm very looking forward to this to this episode. And also, is there uh I so for the audience, if you are the first time watching our entry live, remember to log into your YouTube account, and you can ask any questions you have in the comment area, and we will answer your questions during the show. And also, if you like this kind of contents, please consider like and subscribing our channels. Okay, let's get started. So, would you like to share your screen so we can um, get started
Yeah,
with this cloud provider
yeah,
thing? Okay.
yeah. Okay, you can see my screen, right?
Yeah, I
Okay,
can see that.
okay. Let before everything begin, let me give a brief introduction. uh, so at the beginning, when the Kubernetes starts, you need some. Uh, you have Kubernetes, but it doesn't come out of nowhere. It needs a platform for you, which is the IaaS layer, for you to uh, manage resources like VM and maybe the load balancer, maybe the routes, and then you need something inside your Kubernetes to talk to this layer. At the beginning, we have the in-tree cloud provider. In-tree cloud provider. Why does it call in-tree? Because it's baked into the Kubernetes code.
Hey, Brian, it's very helpful if you could make the words larger so we can see that clearly. Yeah, you're right.
Oh, sorry. Yeah. So we first have the in-tree cloud provider, which code is inside the kube controller manager. Uh,
So IaaS is short for infrastructure as a service, right?
yeah, infrastructure as a service. It could
So
be it could be AWS, Azure.
or vSphere
Yeah.
is what we use at VMware, right?
In our case, it's the vSphere.
Yeah.
So you need something to talk to the underlying infrastructure to help you provision resources. And that SDK used to reside inside the Kubernetes code. If you go to the Kubernetes website today, you will see a folder Kubernetes. It's called Legacy Cloud Provider. Cloud Provider. And that's where you see all the cloud provider code resides. So you have SDK for GCE, Azure, AWS, vSphere, OpenStack, all resides here. That's the old code. Why we don't want it anymore? Because imagine you have the SDK of vSphere inside. Then whenever your Kubernetes is released, you have to make sure that your Kubernetes is compatible with the current or whatever vSphere version you're gonna support. And then that couples the release cycle of vSphere with the Kubernetes. And vSphere is not only one cloud provider. You have other like AWS, Azure, OpenStack. Then your Kubernetes release is tied to all those cloud providers. And it also makes it hard for people to extend their, for example, a new IS like OpenShift today. So that's very that's the issue with the entry cloud provider. That's why uh, like Andrew Saikim and other folks, they worked on this new cloud provider interface, aka the interface, um, which is different. I'm gonna,
That's a screenshot, right?
yeah, sorry. So this is the outer tree cloud provider. From the name, you can tell uh, the cloud provider code was extracted out of the Kubernetes original repo. Then in that way, you can release you can implement this interface. They define an interface so that each IS can implement this interface. For example, you have cloud provider, vSphere, cloud provider, AWS. They implement their interface and then they release on its own cycle, regardless of the Kubernetes version. And these cloud providers, they just need to make sure, okay, I'm compatible with whatever Kubernetes version and with whatever AWS version. Then Kubernetes is decoupled from the underlying IS. Uh, so this cloud provider, they store the cloud specific operations, and let's see what does he really do.
So from here we know that previously the IaaS client is live in the Kubernetes repo, but now we have created something called cloud provider interface. So we decouple the IaaS client with the Kubernetes. So it will be like more flexible and they don't need to release together.
Yeah. So in your class,
so this is where this cloud provider. So this is why we need this cloud provider. But what on earth is the cloud provider?
Cloud provider, it's a set of controllers that do some cloud specific operations. For example, you want to update the nodes with the correct labels, IP addresses, and provider ID, and generally initialize the node with the information provided on the underlying VM.
Okay, so if I run the kubectl get node, does it mean that the information I see from in the result is the result from the CPI's functionality?
Yeah, when you boot up a node with the kubelets, it only registers node, but node doesn't have IP address, the provider ID, some zone region labels. Those are updated by the cloud provider. It only has a uninitialized label, and then cloud provider knows, okay, this node hasn't been initialized yet. Let me initialize it. That's one thing. The other things is like update the service type load balancer and also update specific routes if it needs it. We can go to
Mhm.
the detail later, but generally it does uh, some functionality that operates against the cloud, the underlying
Okay.
IS. Yeah,
Okay. Yeah.
and we can go to the detail of the cloud control.
Yeah. Yeah.
Cloud console.
So what functions do we need to implement um in order to create a cloud provider?
So inside the cloud provider interface, whenever you run a yeah, so the cloud provider interface, it
Mm-hmm.
has several controllers, uh,
Mm-hmm.
or the cloud provider REPL. It contains an interface and several functions. The interface is for each cloud provider to implement.
Yeah.
The general functions, and also it has several controllers. That controllers might call the function inside this interface that implement by each of the cloud provider. In that way, the cloud provider that's how the cloud provider works.
Mm-hmm.
So there are usually four uh, con- controllers. First one is a node controller. Uh, the responsibility of it is to update initialize a node. In, for example, set the provider ID, the node IP addresses, and uh, if Zoom labels are also needed. Then how does it set it then? Uh, initialize node. For example, right now the Kubernetes register node, and then it has a node name, but it doesn't have the ID name or the IP addresses. Then node controller calls the function that implemented inside this interface. For example, find the find the VM by node name on each of the cloud provider. For example, each vSphere, you just gets the node name, and then you assume the node name is the VM name, and then they send request to the vSphere API. Uh, let me draw cloud provider vSphere implements this function.
Mm-hmm.
Implements implements. Okay, I give up. This one implement this function,
Yeah.
and what it does is to call the cloud, call the vSphere to find the specific VM, and now it gets the VM's information. For example, the IP addresses, and maybe the VM has a tag showing which region is in, and it also has the IP address uh,
Mm-hmm.
of that VM. So returns
Yeah. So the node controller talk to the cloud provider vSphere to get the information, to get the IP and other informations about the node, right?
yeah, it
So
returns
so
information.
and it will return the information back to the Kubernetes.
Yeah, then the node controller, okay, now it gets the information of the node, and of the VM, then it updates the node with that information.
Mm-hmm.
Yeah, and also every 5 minutes it will check if the node has been updated, because maybe if you have a DHCP server and some of the VM the lease expired and your IP is changed on the VM, then you need some of the mechanism to watch for those VMs to check if the IP has changed. If it's changed, then update the node with the newest information. So that's what node controller do.
And also, when nodes are created or deleted, this controller will also update the information, right?
Yeah.
Mm-hmm.
If it's deleted, you wouldn't care, since node is not deleted by this one.
Okay, it's just like gathering the correct information, up to
Yeah,
date information.
yeah.
Okay.
And there's the next controller, which is the node controller, a node lifecycle controller. Node life. Sorry. Node life cycle controller. So what does it do? It has a loop that checks for existing VM, see if the 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 node's corresponding VM has been deleted or not. Because sometimes you have still have nodes, like uh, you created a node and some reason the people that manage the vSphere, it deletes the VM from the vSphere and
Mm-hmm.
outside the loop of Kubernetes. Then how does
Mm-hmm.
Kubernetes know? This controller checks for VM's lifecycle
Mm-hmm.
and see if, okay, this node's VM is no longer could be found. So then it deletes the node.
Okay. Wait a second. When a VM is gone, this lifecycle controller will delete a node or find other resources for this node.
It would just delete the node.
Or just delete the node.
Yeah.
Okay.
And yeah, that's so you implement a similar interface like this. Um, and then the next controller, which is route controller.
Mm-hmm.
This controller is used for in some of the cloud provider, for example, Azure. Um, Azure they need allocated IP for the pods so that it can do the SNet when the pod tries to reach the resources inside the virtual network.
Mm-hmm.
Um, for vSphere, we do use the router controller for a specific use case, which is the routable pods. I believe this has been introduced in previous Entry Live. Uh, so generally, you have a pod allocated with the floating IP, and
Mm-hmm.
then you need specific routes to tell the outside network that you want to reach this pod, go to this node, and then you can reach the 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 pod's IP within this CIDR through this node. So,
Okay, so
and
it's a way to expose pod to the outside
yeah,
network.
yeah. So the route controller will talk to the NSXT because vSphere doesn't have a networking infrastructure. Uh, so the NSXT will play at this role, and then route controller will talk to NXT to add specific stack routes to tell
Mm-hmm.
if you want to reach a specific pod CIDR, go to this node.
Okay. So
Yeah.
for the people who first look at our video, so can you like tell us a little bit about what is NXXT?
Oh, and NSXT is a software-defined network SDN. It's a software that manage the your data center's networking resources. Uh, for example, you want to manage the north-southbound networking and add virtual routers within the data center. So to uh, add the tendency boundary between your each of the to divide your network into small groups, more tendency. Um,
It looks like you use a software way to manage your hardware, right?
yeah, manage your networking inside your data center. General.
Yeah, very general. Okay, but for I can find a link for that if you still if you want to know more about that.
Yeah, thanks.
Mhm.
So setting up routes, up routes, your cloud. And the last one is the service controller. Service. So this one, people might be more familiar because sometimes you want to provision the service type load balancer, and then you need some of the uh, you need something to implement allocate the VIP for your load balancer, then implement the routes from the VIP to your backend VM or your backend service. Okay, hello, Fang. You are late.
Oh,
Uh,
Fang is here.
yeah. So Fang is one of the maintainers for cloud provider vSphere as well. Feel free to join. Uh,
By the way, I shared a StreamYard link in the channel, so you can click that link to join us.
yeah.
Okay.
Balancer. In our case, for example, you're on vSphere. Usually use NXT. That's what we support at the moment. So you create a service type load balancer. Then you need something to allocate it IP for that service type load balancer, and then route the traffic from that IP to your machine where the pod is located. Then in our vSphere cloud provider vSphere, we have an SXT code, NXT SDK to talk to NXT to create a load balancer, and then create several virtual server and server pool. The virtual server is the endpoints, the the backend, yeah, the backend of um, the the service, which is uh, the VM where the pod is located. So
So that's the way TQGS implement this load balancer type of service, right?
no, that's TKGM. TKGS use
TQGM.
similar approach, but in parallel virtual
Oh,
version.
okay.
We can
Okay.
go dig into that later, but generally what it does is just talk to. It has some other functions like create service or create load balancer. I forgot the specific name, but
So so in TKGM we but I remember that RV is a different story, right? Because we have like covered that before, and the whole the data plane of that is not on this on the CPI, I think.
yeah, that's difference between the vSphere and the other cloud provider. That vSphere, it doesn't have a networking infrastructure,
Mhm.
or the current VDS function, it doesn't provide the load balancing or setting up routes. It doesn't have that kind of functionality. So we need NXT as the data center networking, uh, managing resources. Uh, so uh, then using AV, yeah, when you use AV, you don't need to do anything inside the service type load balance. Instead, we have a component called AKO, which is another pod, another operator that lives inside your cluster. The cloud provider also
Yeah.
lives inside your cluster. It's a currently it's a cloud provider manager.
Mhm. So Avi has like a totally different way to provide this load balancer type of service.
Yeah,
And
AKO
what
is
we're
another.
is yeah, it's other story.
Yeah. So every time you create a service type LB, this one you might reconcile it, and this one you might reconcile it. Currently, if you don't pass any NXT information to the cloud provider, it won't start this service type load balancer. Otherwise, you will talk to vSphere, talk to NXT to implement the load balancer using NXT. But if you don't pass NXT information and you install AKO inside your cluster, the AKO will reconcile the service type load balancer, and it talks to the AV controller.
Mm-hmm. Yeah.
And then tell the AV controller to allocate a VIP for me and implement the data plane, route the traffic from that VIP to the backend VM where the
Mm-hmm.
pods are located.
Yeah. So if I want to use the NSXT to achieve this load balancer type of service, so after I uh up- after I create an LB service in my cluster, what will happen next?
Um, okay, so with NXT, it talks to some of the service, for example, create service.
Mm-hmm.
Um, and then create a service. Um, what it does, it checks for the backends.
Mm-hmm.
Um, create a service, it will pass informations like endpoints, ports, maybe several, because you have maybe have several backends, right?
Yeah. Right.
And then the NXT, you pass this information to NXT, and then NXT will first create a service type load balancer.
Mm-hmm.
Not service type load balancer, sorry, it's just a load balancer. It's a kind of resource inside NXT, and then it creates virtual server and creates server pool. The server pool, virtual server, I think is the backend. Uh, I might be wrong, but server, it will inside NXT will create resources like the server pool that contains several members. Each of the member is these backends.
Mm-hmm.
Then uh, the load balancer IP addresses, and then it can be routed to this backend service.
Mm-hmm.
With this LB server pool. Did I do server pool? And the pool will contain several members, which is each of these members. And then it implements the data plane that can route traffic to this pool, to each of the members. Then every time, and then it send back the VIP so that the service controller can update the service type load balancer with the correct IP. Load balancer IP inside the status. And that way, every time you send a request to this VIP, you can get your traffic to your expected pods and then return the correct response.
Okay, so the mapping between the service IP and the backend pod lives in the NXST. It's not in like Kubernetes cluster or otherwise.
Oh, yeah, you will also live in Kubernetes. You will also create endpoints. Endpoint is a CRD that stores the backend information associated with the service. Endpoints. Endpoint stores this information. Endpoints. Slides. It's being evolved. Still, the original one is the endpoint. If you kubectl get endpoint, you'll see contains the backends, the backend information of the service. Okay, we have questions in the chat. What functionality subnet between vSphere Cloud Provider and KV, if any? What functionality subnet between?
So my understanding here is that is there any functionality same in both cloud provider and KV?
Okay, yeah, there's no overlapping between these two. The KV, so cluster API is just a way to provision a cluster from specific provider. So what it does is to create a VM and then run the kube ADM command on each of the VM. So it does the cloud init, and then bootstrap the Kubernetes API server controller manager. But then you will see you have nodes, but the nodes doesn't have IP address, the provider ID, because that's where the cloud provider vSphere comes in. It updates the IP address, the provider ID, and initialize the node. So cluster API is just the way to bootstrap the node, but then initializing it is still the job of the cloud provider.
Yeah, that's a great question.
Yeah, people might a cluster API is just a way to provision cluster. You can also use like we used to have TKGI, which is using the Bosch to provision cluster. You just use Bosch to provision VM, and then Bosch will run process like kubeadm. It doesn't run kubeadm. You just start the kubelet API server as a process. Then you still need to either use the in-tree cloud provider resizing the kube control manager, or install the external cloud provider to initialize the node. So these two are different.
Yeah, actually, I asked this a very similar question to Lubron yesterday about this. I'm also confused about that.
Yeah, no worries. Yeah, there's so many concepts. And next question:
Yeah,
Scott
it's
install?
actually not a nice question. Is that
Oh,
is the access load balancer were
yeah,
deprecated a few months ago?
yeah.
I didn't know that.
It will be deprecated and replaced by Avi load balancer. I
Oh,
don't I
okay.
don't know how did they do it because NXT is already like several VMs, the add VMs, controller manager, and then you if you want to install to support Avi, you need the Avi controller, which is core VM, 8 core CPU, and 8 gigabytes memory VM. I don't know why. Maybe for more functionalities, so they will integrate Avi with the NXT. Then the only to replace the load balancer parts.
Hmm.
Yeah,
But it's
and
still a yeah, but it's still a good example of how to use this service controller in a cloud provider, right?
yeah,
Yeah.
and uh, at that time the AKO may not talk to Avi controller; it will directly talk to the NXT. I assume.
Yeah, maybe we can double check that later.
Yeah. Um,
Is there any other comments from our audience? They are like really great comments and questions.
yeah.
Okay, let's continue.
Yeah. So we talked about like how maybe this year only AKO. Oh,
There's
this
another
year.
one.
Hi Jay.
Jay's here, Amim's here, Skull is here, Fang is here.
Scott said maybe on this year we won't need AKO. Oh, okay. I don't know. Then we directly call some API, some controllers like NCP. Maybe they could be part of NCP. I don't know. Because if we just talk to the NXT, then why do we need two controllers? Um, and
Interesting.
yeah,
Yeah, interesting question because Skull is our old friends of Andrea Live. He knows a lot about VMware's like product, even if he doesn't work for VMware. It's
nice.
great to have. I think it's great to have him add here.
Okay. So maybe I can talk a little bit more on the power virtual and the non-power virtual model.
Yeah.
Uh, yeah, we don't use our own product. We just integrate them well and use some script to automate the installation or something. But maybe only the outside people will use it. Our customer will use it. Uh, so if I let's so currently inside cloud provider vSphere, we have two folders. One is Power Virtual vSphere, another is non-Power Virtual one. Why do we have these two? Because we have two products which serves similar goal. One is TKGM and one is TKGS. I'm not sure is this allowed to talk outside the company.
I know that
TKGM,
TKGM is open sourced, right? But I don't know
yeah,
if
TKGS.
TKGS is.
But since we are, uh, oh, we shouldn't talk about the other thing. Sorry, but yeah,
Let's talk about the open source one. We don't want to
but
tell
anyway,
anything that
yeah. Let me
that
just
is not
introduce
open source.
two different model. Yeah, we can only talk about TKGM and TKGS. I won't talk about the third thing. And so TKGS and TKGM. So TKGS is using the power virtual model, and TKGM is using the non-power virtual one. What's the difference is? Imagine you are using the non-power virtual model, which is TKGM one. Every time you want to install CPI, let's say you have a cluster, and then you install CPI, CPI. Then you have to pass credentials of vSphere. vSphere endpoints.
Oh, by the way, so when I run the Tanzu cluster create, when does the CPI is installed?
Async stored by the Carvel packaging. You will uh, deploy the daemon sets of CPI inside the
Mhm.
cluster during
Okay.
the bootstrap time. Yeah,
Okay.
and then when you deploy, you need to pass several credentials for the vSphere because it needs to talk to the vSphere.
Mhm.
vSphere API to, let's say, get the IP address of the VM and maybe talk to NXXT to create a load balancer type service or create routes. Oh, hello, Jianjun. Yeah, if you can help answer what is NXXT. And so, yeah. Uh, so this is the non-privileged one. You see the CPI needs to talk to vSphere and NXT. So you need not only the vSphere credential, but also the NXT credential.
Mhm.
Which is unsecure because you store it on the workload cluster.
So all the clusters, no matter the workload cluster or management cluster, we need this information on each of them, right?
Yeah, that's the problem with the cluster API. On the workload cluster and the management cluster, you need the almost similar credentials if you want to operate. Or
Mm.
not a problem, but this model, how to say?
May not be that
You-
secure because
Yeah,
ideally we only want the management cluster to have this kind of information, right?
yeah, it's totally up to the customer if you want to define. Okay, I wanted this to be the workload cluster and that to be management cluster. Even though you define these two, I mean, you can create a workload cluster through a manager cluster, but there's no real difference between these two. You can still operate on your management cluster, and on your workload cluster, you store all these credentials. So how does uh, yeah, TKGI solve it by running the CPI as a systemd process. So it's not in the secrets of Kubernetes unless you
TKGI
want
resolve it. Yeah. TKGI
unless
resolve it by running the CPS, the systemd process, and then the credential are not saved in Kubernetes secrets.
yeah, and it doesn't allow the host path mount. I remember, so that you cannot get credential from the process.
Mm-hmm.
And then on TKGS, how do we solve it? It treats the supervised cluster as a super secured cluster, and only the admin can access the supervisor cluster.
Mm-hmm.
Supervisor.
So supervisor cluster in the TKGS is the same as the management cluster in TKGM, right?
Similar.
I mean, they are the
The roles,
same role, but
yeah,
implement in a different way.
yeah, implement in a very different way.
Mm-hmm.
Um, and then the CPI. In this case, if you want to you initialize a node or create a service type load balancer, you don't directly talk to vSphere or NXXT. You have specific permission to provision specific resources inside the supervised cluster. Let's say you can provision um, a virtual machine service. Yeah, under our statements. So if you want to create service side load balancer, you provision a virtual machine service, which is a CRD inside the supervisor cluster, and then there are some components inside the supervisor cluster, like NCP. It will reconcile the CRD and then talks to vSphere or an NSXT to create a service type, to create a service inside an NSXT. Then update the CRD, and then CPI gets the new updates and updates the service type LB inside the workload cluster. So you can see even this detour all the way to the supervisor cluster to just to provide to create a service type LB. This way, you don't store any vSphere or NXT specific resource credentials inside the workload cluster. Then, even though you have then you don't have access to those, and even the credentials stored on the nodes, you still have the risks that customer might have the post path mount permission to get those credentials. That's one of the reasons the TKGI you don't run the kublets inside the control plane, because control plane store all the important credentials, and they are afraid that people might get those credentials through pods. In TKGS, the supervisor owns all the secret stuff. That's meant by private virtual hardware virtualization environment. The kernel owns all hardware interrupt and exposed virtual hooks. Yeah. So the supervisor cluster is like the kernel that owns all the credentials and only expose specific operations, the secure operations. Like you can create a CRD, but you are not allowed to mess up with the supervised cluster unless you do DDoS, like create billions of CRDs. That's the way, but it's much more secure.
Yeah. So yeah. So far, is there any other questions? Okay. Um. Yeah. Is there is there any other oh, by the way, is there any other things that about the GKGM that you want to share with us, Lubron? Is that
Uh,
everything we prepared?
CPI is responsible for the LB uh, and node initialization. There's another component we call CSI, the storage interface.
Oh, right.
Yeah, we also have a vSphere cloud storage component that implements the persistent volume,
Mm-hmm.
the managing of the persistent volume. It's the storage side. That's similar. Yeah, I think TKGM. Yeah,
Yeah.
currently, let's see. Yeah, I think that's pretty much covers it.
Mm-hmm. Yeah, yeah, that's awesome. And I also like remember like you said yesterday that we want more developers on the cloud
Oh
provider
yeah,
vSphere.
yeah. Feel free to. We have a meeting every 2 weeks on Wednesday morning.
Mhm.
Okay, not today, but next week. Next week we have a SIG meeting. Um, so each of the cloud providers maintainers will join the meeting and come check with the current status of each repo, each repo, and see for what we can do for the future of the cloud provider. Currently, it's more like um, maintenance and test coverage increasing. But yeah, we are looking for new ideas. And one of the main work we've been doing at the moment is uh, the extraction, migration extraction, because we are deprecating the entry cloud provider in 124. And not deprecating, yeah, deprecating. If you still use that flag, it will warns you. Okay, we don't want to support the entry one anymore. So that's one of the important work at the moment. Yeah, just if you want to contribute to our repo, you feel free to join this channel provider vSphere inside the Kubernetes, and yeah, we have uh, welcome to contribute.
Okay. Okay, that's awesome. Okay, if there's no further questions, uh, let's end this great episode of the introduction to the cloud provider. So hope you learn more about it, and at least you know the what it is and what it looks like inside. So next week, Grace will come back for his second episode. And thanks everyone for watching. See you next Wednesday.